Today we're going to continue our work with box plots as a method of representing data. We have three objectives today. They are that given a box plot, we can estimate the values that make up the 5-number summary. We can describe a data set using the 5-number summary and the interquartile range, and that we can construct a box plot from a 5-number summary. 94 people were asked to grab as many Tootsie Pops as they could. Here's a graph of the data. This is a box and whiskers plot, just like the ones we worked with yesterday. We need to be able to read this graph in order to understand more about the data. What is the median number of Tootsie Pops a person can hold? Reflect on our work yesterday with identifying key parts of a box plot. We learned that each box plot provides us a 5-number summary. These 5 numbers are marked by lines on our graph. These include the minimum, first quartile, median, third quartile, and maximum. The median is always the line inside of our box. This line is at 20, meaning the median amount of Tootsie Pops a person can hold is 20. We could take this a step further by finding the 5-number summary. The 5-number summary lists all 5 of these values in order of smallest to largest. We started with the minimum value and list each labeled point up to the maximum value. Pause the video here while you come up with the 5-number summary of this box plot. The 5-number summary of this graph is 7, 18, 20, 22, 42. Consider this statement. More people could hold between 22 and 42 Tootsie Pops than can hold between 20 and 22. Is this statement true? The people who could hold anywhere between 20 to 22 Tootsie Pops are between the median and third quartile, while the people who could hold between 22 and 42 are represented between the third quartile and the maximum point. Someone might make this claim because the 22 to 42 range covers much more of our graph than the 20 to 22 range. Remember, however, that the box plot is designed to measure variability. Even though they cover different amounts of space, each quartile of our box plot holds 25% of our data, the same number of data points. This means that there were the same number of people who could hold between 20 and 22 Tootsie Pops as there were who could hold between 22 and 42. The key difference is that the people who could hold between 22 and 42 were much more spread out, or had a much greater variability, whereas the people holding 20 to 22 Tootsie Pops all held very close to the same amount. A possible representation of this data could be shown in this dot plot. Notice how there are only a few select outliers that make our final quartile cover such a wide range, whereas our interquartile range contains many clustered data points. As you progress through today's lesson, you're going to continue interpreting and creating box plots.